Okay, the second problem is a little more involved problem. So once again, pay careful attention and work the problem along with me. So here we have a dry cleaning company that cleans on the average 2,000 pounds of hospital laundry and 3,000 pounds of hotel laundry. So there are two different outputs. The company charges $4 per pound for the hospital laundry and $3 per pound for the hotel laundry. So with these dollar amounts, we can convert the units into dollar amount. They use 3 workers, 40 hours per week, so that's one input, labor input, and the workers are paid $12. And then on the average, a load of hospital laundry requires 5 gallons of cleaning agent. So cleaning agent is a second input, okay, and then 4 gallons for hotel, okay, and then each load is 50 pounds. Cleaning agent costs $3, and then there is a third input, which is energy. Okay, on the average, each load uses 3 kilowatt hour. Okay, so now we want to determine the present multi-factor productivity. So let's start with output. So we have hospital laundry equal to 2,000 pounds per week at $4 per pound. So the output is per week is $8,000. So all the calculations are per week. Next is hotel laundry. And that is 3,000 pounds per week at $3 a pound. So this works out to $9,000 a week. So total output per week is $17,000. So that's output. So now let's look at input. Remember, there are 3 inputs. Okay. So let's take the first one, labor. Okay. So we have 3 workers times 40 hours per week times $12 an hour. Okay, so that's all given. So that is equal to $14.40 per week. So labor cost is $14.40. Second input is cleaning agent. And cleaning agent is little involved in computation here because this is based on number of loads. So number of loads per week, okay, times gallons per load times $3 per gallon. $3 per gallon is the cost for the cleaning agent. So we have to first determine these two. So number of load. So this, okay, let's look at this for each product. So for hospital, the number of loads per week is, we have 2,000 pounds, okay, and each load is 50 pounds. So if you divide 2,000 by 50, so that will give us the number of loads for hospital. Then times, hospital requires 5 gallons, so 5 gallons per load times $3. So that gives you $600. Now for hotel, we have 3,000 pounds and 50 pounds per load. So that gives us the number of loads times. Now this requires only 4 gallons per load times $3. So gives you $720. So total cleaning agent per week is $1320. So now we have the first input, we have the second input, and we need the third input, which is energy. That is equal to total number of loads per week times 3 kilowatt hour. Okay, so we have 3 kilowatt hour per load times 20 cents. So that is equal to, okay, so here is the number of loads for hospital, that is 40, okay, and that 40 comes from here, plus 60, and the 60 comes from here, okay, times 3 times 0.2 gives us $60 per week. So that's our third input. So total input then is 1440 plus 1320 plus 60. So that is 2820 per week. Okay, now with this we can now compute the multi-factor productivity. Multi-factor productivity is now output, which is here 17,000, okay, divided by input, which is 2820, that is 6.02837 per dollar of input. Now how many decimal places you should keep? Well, there is no single answer. This is not an accounting class where you keep 2 decimal places. So it depends upon how big the number is. Smaller the number, the more decimal places you need to keep. So here, especially in productivity computations, I would keep like 4 or 5 or even 6 decimal places. Okay, we'll do B in the next video.